Hey everyone, as discussed in the last two videos, if you're just starting out with Arduino, you've probably seen some weird looking words in the code like pin mode, digital write or delay. They are built-in functions that make programming your Arduino easier and faster. In this video, we're going to explore some of the most commonly used inbuilt functions in the Arduino IDE, what they do and how you can use them to control your projects. Firstly, what are built-in functions? In the Arduino world, built-in functions are pre-written commands provided by the Arduino programming language based on C or C++ that you can use to read from sensors, to write to LEDs and motors, or to handle timing, to communicate over serial, and many more. These functions save you from having to write low-level code. Arduino does the heavy lifting for you. There are some basic structure functions. These are the core of every Arduino sketch. We have the setup function. This function runs once when the board is powered or reset. It is used to set pin modes, initialize serial communication, etc. This is the most important function to run any program. As soon as we open Arduino IDE, we'll be having void setup and void loop, both of which are inbuilt functions, which are basic structural functions. In setup, we generally write codes or functions like pin mode. This function will help you to declare the pins and which pins you're using for which sensor in the Arduino. So in this void setup, we can see that setup is highlighted in orange. So after setup, we use parenthesis to call this as a function, and then we open a flower bracket, and in between the flower brackets, we'll write whatever code is required. And it is important to always close the flower brackets. Next, we'll look at some digital input-output functions. Firstly, we look at pin mode. Pin mode is a function that is used when you want to set a pin as input, output, or some input pull-up. So the basic syntax is like this. We have pin mode and the M should be in capitals, and then in the parenthesis we write the pin number and whether you want to make it input or output. Also, what we can also do is we can first name a variable, like for example LED, and then we can declare the pin number in the before the setup, and then inside the setup in pin mode function we can call the variable instead of using the pin number. This would work too. Secondly, we can change it whether if you want to make it input or output, or you can also make it input pull-up. Now coming to another function, we have digital write function. Digital write function is used when you want to send high, that is 5 volts, or low, that is 0 volts to a digital pin. So the syntax, basic syntax is digital write, where W should be capital, and then inside the parenthesis we write the pin number, which is for example 13, or you can also write the variable and then comma, and then you write either high or low depending on if you want to make it 5 volts or 0 volts, and after that we end it with a semicolon. Then we also have digital read. Digital read is used when you want to read inputs from a sensor. So we'll write digital read where R is capital and then the pin number. There is no high or low, as you are reading the value and not giving the value. So we can also write it as another variable, like we have int button state. So we have int button state is equal to digital read 13. So whatever reading we get from sensor that is on pin 13, we get it into button state. Let's just give it a new pin because we use 13 for the LED. Now we'll look at some analog input output functions. So firstly we'll look at analog read. Analog read is a function that reads a value between 0 to 1023 from analog pins. So we have analog pins A0 to A5. So we just need to write analog read with R capitals, and then in the parenthesis we have to write the pin number. So we'll give A0 for example. So we have 5 analog pins in the ArduinoUno. So we can write any pin, any analog pin, and analog read will read the sensor's value from that pin. What we can also do is we can write int sensor value and just make a new variable, and then we can store the sensor's reading in that variable. So using a similar function, similar line of code like this, we can simply store whatever the value the analog read function will return into the sensor value variable. And after this we can also use the analog write function. Analog write function is not used for analog pins but is used on digital pins that use pulse width modulation. So what analog write does is it sends a PWM, that is pulse width modulation signal, to simulate an analog output. So using this syntax analog write, what we can do is we can enter the pin number. For example, we can say maybe 9, and then we can write the value. It can be around, for example, 128. So what this does is 128 is half of 256. So it will run this at a 50% duty cycle. It is important to note that it only pins that have the tilde symbol, the digital pins that have the tilde symbol, only those support PWM. Alright, so now let's look at some time functions. So for example, we have the delay function. So what delay does is it's a function which is used to pause the program for some specified number of milliseconds. So when we enter delay 1000, for example, 1000 is in milliseconds, so the program is delayed for 1 second. And we also have the function millis. So what this function does is it returns the number of milliseconds since the program started. So once we run the program, whatever is the number of the amount of time it ran for in milliseconds, this function will return it. So we can use a data type called unsigned long, and then we use the variable name, for example time, and then we can assign the variable, and we can store the millis, whatever the value is returned by the millis function into this time variable. Similarly, we also have another function called delay microseconds. So what delay microseconds does is that it does the same function, but this time we enter the time in microseconds instead of milliseconds. So this time if we give a million, then a million microseconds is equal to 1 second. So delay 1000 is similar to delay microseconds 1 million. And similarly, like millis, we also have micros. This function is have a similar function like millis, but returns the value in microseconds. So delay microseconds and micros is used when dealing with microsecond level timing, which are used for fast sensors or communication. Okay, now we'll talk about serial communication functions. I'll just quickly comment these out. So serial communication is used to send and receive data between Arduino and your computer. So to start this serial communication, we use serial.begin, and we write the baud rate in parentheses. Generally 9600 is used, and it starts the serial communication at a certain speed, that is 9600. And then in the loop we use serial dot print, and whatever we want to print goes in the parenthesis. We can either print a string like hello, or we can also print a value like away from a variable. So for example, we can just get the sensor value and we can print it in the serial monitor. Serial dot print ln is used to print the values in a new line. Serial dot print prints the values in a continuous string, but serial dot print ln will give the values in a new line. Similarly, we also have serial.read. This function will read the incoming data from the serial buffer. So we can use something like int data is equal to serial.read, and whatever is the data is coming from the serial.read or the serial buffer will be stored in the data variable. Arduino also has some built-in math functions to make calculations, and they're called maths and utility functions. So for example, we have the map function. So what this does is it remaps a number from one range to another. So by using something like int mapped is equal to map sensor value comma 0 to 1023 and mapping it into something like 0 to 255. So what we have done here is using the map function, whatever the value is given through the sensor value, that is the analog value, we mapped it from 0 to 1023 to 0 to 255. So what this does is, if the sensor gives a value like 0, then in our sensor value it will be stored as 0. But if it gives something like 1023, we mapped it to 255. So 50% of this will be 50% of this. So like there will be a proportional numbers. So we have, if for example we have 512 that is given by a sensor in the analog pin, then it will be mapped into 128. So this is a useful function when you want to limit or you want to map something into a smaller range. We also have constraint. This function will limit a value between two boundaries. Like for example, we have int safe. Like for example, we want to make sure that the safe value is between a certain range. We use constraint function, and in the parenthesis we write the sensor value, that is the variable, and then 0 to 100. So any value between 0 to 100 is safe and the value is constrained. Anything above is not taken to the sensor value. And we also have some math library functions like ABS, which is the absolute value, or we have POW, which is for power, and then SQRT, which is square root. They are like in standard math libraries. So why are these built-in functions useful? It's because they are simple and reliable. So they save time and reduce the chance of errors. And these built-in functions work across all Arduino compatible boards. So they are widely documented and easy to find examples. These built-in functions are the backbone of Arduino programming. Once you're familiar with them, you'll be ready to build everything from blinking lights to home automation systems. It's okay if you don't understand some of these functions. We'll look into those into more details when we are making projects. That's it for today. Until then, goodbye.